I want to take a moment and make sure you guys have a calculator here. We're going to write some basic exponential functions, and then we're going to find the value after a certain number of years. So let's look at the first one. The first one says a town has a population of 5,000 people and grows 3.5% every year. What will be the population after 15 years rounded to the nearest whole number? So I want you to write down this formula at the top of your page. You remember this? Okay. It loves you. Oh, that's not true. I love you. Okay. So I'm going to read this for you, kind of how I read this in terms of this mathematical formula. You're after it in time. It is a t. This is the amount. See the capital A? The capital A is the amount at time t. So the amount in 15 years, all right, equals, do you see this little a, the lowercase a? This lowercase a is the initial value or the initial amount. All right, so your starting point. All right, do you see R? R is the rate at which it's growing or decaying. I wrote plus or minus, but I need you to choose which one. Don't put plus and minus. Choose which one. If we're growing, we'll be using addition. If we're shrinking or decaying, we're going to use subtraction. So you're going to choose one. And then you see where the t is? You see where t for time is? Where is it? It's in the exponent. Hence, Luke, why these are called exponential functions. Okay? All right, here we go. So the first one. Thank you, Luke. What's my initial value for the population in this town? 5,000 people. No worries, Luke. It's okay. One, are we getting larger? Are there more people in this town now, or is it less people? More. It's growing. Nice. So I'm going to put plus. Can you guys tell me what 3.5% is as a decimal? 0.35. Right? Because if you said 0.35, that's 35%. Remember, you got to move it over 2 places. Do I need to show that? Should I show it? Okay, just in case, Hector, that you don't. Okay, I'm going to move it over 2 places. So 1, 2. So it's 0.035. You guys see that? That's how you find the decimal. Okay, don't forget. This needs to be raised to the power of t.
What's t?
What is t?
Time.
It's time. Right? T time. All right. Sure. So we're doing 15 years. I had a feeling, but since I'm old. We were at some restaurant outside Chicago when I was on vacation a few weeks ago with my family, and they were playing. Oh, no, we were at a football game for my niece is in the marching band. And they were playing all these songs before warm-up, but it was all songs, like hip-hop songs from like 2008, 2009, like right as I was like graduating college. I was like 21, 22, and I was like, oh, man, I was feeling it, right? Ready? And my children were like, what are these songs? And I was like, oh, just the best. Okay. Which one? Is this a 1? It's a 1. It's a 1 plus. If you'd like, I'll put this to the side. It's up to you. I don't care. Both are correct. But if you'd like, you could rewrite this as 1.035 to the 15th power. Like you could write this like that. Exactly. If you wanted to put them together, it's your choice. I don't care. All right. Both. If you typed in my whole thing, I guess I should highlight everything. If you typed in my whole thing, or if you typed in that whole thing, you should get the same thing. I don't care. It's your choice. Okay. So do you guys have your calculators? All right. Type in whichever way you're choosing. Whichever way. Do you need to calculate? Yeah. Well, don't need to type in the A of 15, right? I'm talking about after the equal sign. You're going to type in the 5,000 times, and if you want to put them together. Do you guys know how to get to the exponent? Do you know what button gets you to the exponent? The dot. It should be like the caret. Kind of looks like a little bit like an arrow. It's diagonally from the number 7. That'll get you to the exponent. Make sure you find someone around you and compare. Like Isaac, make sure you turn around, make sure Gabe's got it. Joma, make sure Samantha, you guys make sure each other have it. You got to make sure, you got to type. Gladys, you want to type it in, right? Practice. Did you turn around and talk to Minerva, make sure you got the same thing? What'd you get? Now it says round to the nearest whole number. So Hector, what are you writing if you're rounding to the nearest whole number? 8,377 people. Right? Because that 0.7 nearest, it says the nearest whole number. Yeah. You can't have 0.7 of a person. What the heck? 8,377 people. Did everybody check with someone? Did you check with someone, make sure you got it? Yes, Jasmine, Luke, did you guys check with each other to make sure you had it? Okay. Okay, any questions on number 1? Remember, I am recording. I am recording. For my YouTube. Yes, so they're listening to you guys.
Hi guys, welcome back to our channel.
Thank you so much. Make sure you like and subscribe with personal and school account. All right, number two. We purchased a new car.
Oh, that's it?
That was it. Did you want me to circle it? I got you.
What about the 15?
So the 15 just means the amount in 15 years. So it's just, you read this as in 15 years, this is how many people I expect live in that town. Okay? All right, so we go and purchase a new car. Nice. It must not be super nice because it's a new car and only 17.6. That must be pretty small. Okay? The value of the car depreciates. You guys know that word, depreciate? It decreases. It goes down, right? There's a reason that I try not to buy new cars if I don't have to, because the moment I drive the car off the lot, it loses value. All right? So it's going down per year. What's the value of the car to the nearest cent after 11 years? Let's write down our formula. The amount at time t equals, what is the starting value of the car? How much did I pay for this car? $17,600. 1. Now this is your choice. Am I going to be writing a plus sign or a subtraction sign? And how do I know that? Because of the word depreciates, right? You always need to be able to point to a word in the problem that's telling you it's growing or it's shrinking. In this case, depreciates means it's going to lose value. Yes, student. That was Hector, by the way.
Hello, sir. Hello, gang. In this sense, since it's at 11, how are you supposed to plug it in the decimal? You divide by 11.
No. All we have to worry about for the 11 part is just that's going to be our t. That's going to be the power. So you don't need to worry about the years yet. Let's make sure we have the formula first, and then we'll worry about how many years are we. Because 11 years. My car, I've had my van since 2017, so we're approaching 8 years, right? Or 7 years since I've had it. So that's a long time to have a car. 11 years is a long time. Inside, if you get past all the goldfish and Cheez-It dust and all that, sure, it's super bougie. All right, so I seem pretty bougie, right? Yeah. Didn't feel low key. Now, the rate. Do I need to do this again? The rate is 11.75%. So I want to move it over 2 places. So this is going to be 0.1175 raised to the power of t. Now I'm going to, you're right, there was Bella and Minerva. I am going to plug in 11 there, all right? But right now I just want to make sure, do we have any questions on writing the formula? Now you have options. Do you guys want me to subtract this? I can. Do you want me to subtract this? Yes? Okay. Isaac said yes. So let's do it. You don't have to, is what I'm saying. Okay, so it'd be what is this going to be? 8.25. Can somebody check my math there? Can somebody do 1 minus 0.1175?
How'd you get that?
Is it 0.8825? Okay. Say it again.
How'd you get that number?
0.8825. I subtracted 1 minus 0.1175. You don't have to do that, Luke. You can get the right answer. Some people like to do that.
I did that.
The reason say it again.
I did it over.
Oh, you got the answer. I'm not getting the answer yet. Did you raise it to the 11th power?
Yeah.
Okay, then you have the answer. I am just trying to show you how you can rewrite it. The reason I like to do this sometimes is because what do you notice about this number? What do you notice about that number? What do you notice about 0.8825? I'm hoping that you see it's between 0 and 1. So if your base, this is our base for an exponential function, is between 0 and 1, this is called exponential decay. And are we decreasing in value? Yes, so this should be between 0 and 1. You don't have to necessarily know that to get these right, but it's good to know about exponential functions. All right, so now I'm plugging in 11 where it says T. So essentially the value of my car in 11 years, and did you check with someone around you, Hector? Make sure you got the right thing? Minerva, did you get the same thing?
What you get?
Yeah, you got the same thing. Now it says to the nearest cent, so it looks like that's going to be $4,450 and. But wouldn't that 8 make that a 15 cents? Did you get that, Isaac? Somebody said why though? Was that Gabriel? No. Who said why though? No, it wasn't Gabriel. I'm sorry. Somebody said why though? Was that you?
She was like, why?
It definitely was not Minerva.
You didn't hear her deep voice?
I did not. Gabe, you okay over there? So it's going to count it wrong if you put 0.1, right? Because it says nearest cent, so you need to put to. Well, yeah, but that's not. If you put 0.1, that's 10 cents, right? Wouldn't that be 10 cents? Okay, you guys ready for the last one? Are you already doing the next one? On the link?
Yeah.
Look at you, Jasmine. All right, I see you. Okay, here's the last one. We have $7,900 placed into an account with an annual interest rate of 5.5%. How much in our account in 11 years? So I'm going to write our formula again. How much money am I depositing into the account? 7,900. Oh, that would be nice. Can I get some of that? 1. Now, am I writing plus or am I writing a subtraction symbol? Plus. How do I know that? Because in this case, we're assuming that our money is going to grow. 0.055 to the power of t. So I'll show you guys kind of what I did on the last one. So this is 1.055 for our base. And again, to keep with the continuity from the last question, if you look at this base, that number is greater than 1. So if it's greater than 1, we should be assuming that things are growing here. This is exponential growth. Plug in your years, which is 11. It's not always going to be 11. All right, again to the nearest cent. Let's see, someone got 14. We got 14. We got over here. You got 14. You still doing it, Michael? Okay. Let me see over here. They've already started working on the link. Did you type it in, Bella?
14.
Not yet. You're good. No, you're good. I just want to see. You type it in? That was number 2, right? All right, so I saw 14,000.
She gave me a 14.
Did you get the same thing, Manuel? 236.53? Nice. Let's not make that the last thing they hear on the video, right? Whenever.
They made me so happy, guys.
There you go. Yes. So good luck on your Delta Math link. And come see me in office hours if you have any questions. Say bye.
Bye.